Video we'll be looking at a coding implementation of our neural network layer. So we do have two particular examples. So one is a coffee roasting and the other one is for image recognition of a digit between 1 or 0. So as you can see over here, the very coffee roasting scenario, what we are trying to do is that we are trying to know which particular beans are being roasted perfectly and which are not. So in order to mimic a particular scenario like this, what we have done is that we have got two variables. I know it's more complex than this, but in just to make it more simpler, we have got two particular variables. One is for how long the coffee is being roasted for, and the other one is the temperature at which the coffee is being roasted. So as you can see, we do have four particular type of coffee. One is being undercooked, which is it is being cooked for high duration but at lower temperature. The other one is too short duration, where the duration is very low but it's being actually roasted at high temperature. And the other one is overcooked, which means that very high temperature and high duration as well. But then you also get the particular sort of coffee which are being roasted at the moderate temperature and also for the most optimum time as well. So what we are doing is that we are actually feeding in the value of duration and the value of temperature to the layer 1, and then what the layer 1 is gonna do is that it actually gonna generate the activation value and fed it to the layer 2, which is gonna be responsible to figure out if the coffee bean has been roasted perfectly or not. So in order to do the coding implementation for this model, we will be using TensorFlow. So if you guys don't know, TensorFlow is an open source machine learning framework, and it's actually designed for much more large level LLM models and very much important for deep learning models as well. It's similar to PyTorch, but this one is developed by Google, whereas PyTorch is developed by Facebook. So we are gonna use this particular library in order to implement this. If you see over here, what we are doing is that we are declaring the X, I mean the particular values of, I mean the particular attributes which are being fetched to the layer 1, which is 217. If you see from here, we were trying to input the value of temperature and duration, right? So temperature in this case is 200 and the duration is 17. We are basically declaring the particular X value in the form of array over here. So as you can see, we have got a matrix which is 1 into 2, which means that it has got one row and two columns. So 200 comma 17, and then that we are declaring the layer 1 and saying that it's actually a dense neuron, and then we are saying that it has got a unit 3 and activation is value is equals to sigmoid. So I will explain you what this means. So dense is the sort of neuron which is connected to all the neurons to its previous layer, so that's where we are saying it's a dense. And then unit 3 means that we have got 3 neurons. So if you look over here, we've got 1, 2 and 3, so there is 3 neurons in total in layer 1. And then we're saying is that the sort of algorithm activation is gonna use is sigmoid, so that's why we are declaring it like this. Then what we are doing is that we are saying that the value which is gonna be generated from layer 1 is equals to activation value and activation 1, which is the truth, right? So the layer 1 will be responsible for generating the first activation. We are calling tf.tensor. So tensor is a sort of data type which is used to show metrics. So as you can see, we have got the output of 0 0.2, 0 0.7, 0 0.3. These are actually just dummy data in order to just show you how it works. So as you can see, it is 1 into 3 metrics. That means that it doesn't have actually any row in it, but it has got 3 columns, which will be actually used in layer 2 when it comes to coming up with the ultimate sigmoid function value. So if you want to convert this particular data which was outputted in the form of tensor into numpy, what you just need to do is just say a1.numpy. So this data type would be converted from tensor into numpy. So what we have done for this long is to declare the layer 1. We do have to declare layer 2 as well. So in this case, the building block are layer 1 and layer 2. So this is the proper implementation. What we are doing is that we declare layer 2 in the same way which we did for layer 1. But in this case, we have only one unit. As you can see, we do have only one neuron over here. Otherwise, it's exactly the same. So and then we are declaring the x in the form of array over here, like the way we did before, instead of just declaring one particular data sets. We are declaring all of them, and along with the y target values. And then just before using this, what we do is that we compile it, and then after that we can start using this model. What we have to do is we have to use model.predict, and give the x value for which you would like to predict the y value. So now let's look at the other example. So over here, as I said, this is a model which will be able to recognize if the particular image has got 1 or 0 into it. So in the very first, what we're doing is that we're declaring the x values, but in this case, x values over here, that which we are declaring the form of array, is not the temperature duration, as it's image recognition. We do need to fetch the value of pixels, right? So for example, a particular image which is square size, it needs to have all the pixel values, like starting from 1 2 3 4 5, right? So we are declaring all the pixel values, as you can see over here. Then what we are doing is that in the layer 1 we do have 25 neurons instead of 5, because we do have a lot of inputs, right? Instead of just duration and temperature, we do have all the pixel values, and the otherwise everything is the same. Activation is still sigmoid. And then in layer 3 we actually come up with the value if it's gonna be 1 or 0. So if the final value, I mean the activation A3 value, is more than 0.5, we'll be able to say it's 1. Y hat is the predicted Y value, or otherwise it's gonna be Y0, which means that the predicted Y value is 0. So there is actually one other thing which we can do to make it a bit more automated. Like as you can see, we are coming up with the activation value and then fetching it to the next possible layer. We could actually automate it, that we'll be declaring a model and saying that the layer 1 and layer 2, those are actually in sequence, and in this way the model will be able to figure out that which activation value is gonna be fed into which particular layer. So if you would like to make the code even more smaller, what you can do is that instead of declaring layer 1 and layer 2 first, you could declare layer 1 and layer 2 directly inside the sequential function. In this way the code would become way smaller. I know it's very surprising of how we can actually do such a big thing in just 5 lines of code, but what we'll be doing is that from next week onwards, instead of using TensorFlow, we'll be trying to do it manually by ourselves using NumPy. I hope all of this actually makes sense to you. And don't forget to do one thing, don't forget to follow me for more machine learning contents. Thank you, bye.